Hello everyone, this is Mr. B. Today we're going to be talking about theorems about triangles. So the first thing we're going to talk about is isosceles triangles. Now, an isosceles triangle, what we know about it so far is that it has two congruent sides. What we want to know about it is if the sides that are opposite these congruent sides are also congruent. Now when I say opposite, I mean the side that, or the angle that does not touch the side. So if we're talking about this side right here, these two angles are adjacent to it. They touch it. This angle over here is opposite that side because it doesn't touch it. All right, so for my proof, it's going to be an informal short proof. So here we go. I want to draw an angle bisector on this triangle from the side that is in between the two congruent sides. Now, you can do this for any triangle. I can always construct an angle bisector. And the definition of that is that it cuts it in half. It bisects the angle. So that lets me know automatically that this angle is congruent to this angle. Now, that also cuts the triangle into two different triangles. We've got a triangle here and a triangle here. All right, I'm going to name these real quick just for the sake of brevity. I'm going to name the big triangle, triangle A, B, C, and I'm going to name the bisector here B, D. So we've got two triangles now. We've got triangle ABD and triangle CBD. Now, if we can prove the two triangles congruent, we can use CPCTC to say that the two angles that we're wanting to prove congruent are congruent. CPCTC, if you don't remember, is corresponding parts of congruent triangles are congruent. Now, when we talked about congruent triangles, this kind of picture came up a lot. And it was, are these two triangles congruent? And your answer was, yes, they are congruent by side, angle, side. And the reason we know that third side's congruent is because they both share BD. It's congruent to itself. So we know ABD is congruent to CBD, which means that angle A is congruent to angle C by CPCTC. So let me take away all the extra stuff now. That was an extra. It was part of the original right there. Let me just take away the rest of that. All right. So now looking at the triangle stripped down, we notice that, hey, those opposite sides or those opposite angles were congruent to each other after all. So let's use that theorem now. Let's say we've got this triangle. And in this triangle, let's say that this angle right here measures 70 degrees. And we need to find either one of the other two angles. It really doesn't matter now. They can give you one angle and you can know all three. Okay, and the reason why you can know all three is because if this one's 70, and this one over here, the other one that's opposite the angle, would also have to be 70. Okay, and then this third angle up here, since there's only 180 degrees in a triangle, we've already used 140 of them between these two angles. So this one up here has to be 40 degrees. Another thing they may ask you is they may give you that third angle and ask you what the other two are. Well, since it's 180 minus 40 is 140, well then you just take that and divide it by 2 to get your remaining two angles. So that's 70 once again. All right. So this next theorem, we're going to have to use a different method of proving to prove it. So just bear with me. We'll make it through it. This method of proving is very powerful. It's called proving using a coordinate proof. All right, so the midsegment theorem, by the way, this will probably have a good chance of being on your final exam. It was on the released final exam, which is a pretty good indicator that you will see this used somewhere on your final. So You need to make sure that you know how to use it. It's not that hard. So the theorem itself says that in any triangle, a segment joining the midpoints of any two sides will be parallel to the third side and half its length. So I want to draw a mid-segment on here. So I'm going to find about the midpoint. I'm just going to kind of sketch it, but let's say that's the midpoint of that side. That means that part's congruent to that part. And let's say that this is the midpoint of this side, which means that this part is congruent to this part. All right, I'm going to go ahead and name this triangle A, B, C, and I'm going to name this D and E. All right, so let me draw my mid-segment real quick. Connecting these two. All right, so we're wanting to show that this segment is parallel to this side and half its length. All right, so the first thing I'm going to do is I'm going to put coordinates on here, but I'm not going to use numbers. I'm going to use variables because if I use numbers, it's just an example, and we can't prove it using an example. You can disprove it with an example, but you can't prove it with an example. So we got to use something that will work no matter what numbers we throw in there. All right, so let's say that point A here is at x1, y1. Point B is at x2, y2. And point C is at x3, y3. So in order, I want to prove that they're parallel first. And then I'm going to use properties of parallel lines to prove that it's half the length. In order to prove them parallel, we need to look at the slopes. The slope for this third side, side AC, is easy enough to find. Slope formula says that you have the difference in the y's on top and the difference in the x's on the bottom. So we've got y3 minus y1 over x3 minus x1. I just took this as the first y value minus that y value goes on top. The x values go on bottom. Now, before I can do that for the mid-segment, I've got to figure out what the coordinates for the mid-segment are. So I'm going to have to use the midpoint formula. That's all these formulas coming back from Math 1 or Algebra 1. You should remember them. You're expected to have remembered them since you have already passed the Math 1 class. All right, so to find the midpoint, you take x2 plus x1 and divide it by 2. That's the average of the x's. And then to find the y coordinate, you take the average of the y's. So y2 plus y1 divided by 2, just like that. Okay, and for this one over here, same deal, average of these 2 points this time. So we've got x2 plus x3 divided by 2, and y2 plus y3. It's a horrible, why my handwriting's getting horrible. And divide that by 2, and that is the coordinates for that point. So now once again, I have to find the slope of DE. Okay, so I'm going to use this as the first point. This is the second point. All right, so we've got x2 plus x3. Well, I'm supposed to do the y's on top, so let me just move this down to the bottom. We've got y2 plus y3, that's this one right here, over 2 minus this point right here, y2 plus y1 divided by 2. And that's over this x values. So x2 plus x3 divided by 2 minus this x value, which is x2 plus x1 divided by 2. All right, and now I just have to simplify this monstrosity of a fraction with fractions in it and subtraction. which is easier than it sounds because we have common denominators in the numerator and denominator already. So right here we can just combine the top part to, let me change colors, to y2 plus y3 minus y2 plus y1 over 2. And then in the denominator, same thing with the x's. We've got x2 plus x3 minus x2 plus x1 all over 2. Now, when you subtract like this, you can distribute that negative in and change all the signs. So that's what I want to do. It becomes a plus, that becomes minus, that becomes minus, that becomes plus, that becomes minus, that becomes minus. And now it can combine uh, like terms. So changing colors once again. We've got right here the y2 minus y2 cancel out. And so we're left with y3 minus y1 over 2 divided by, now the x's, same thing with the x2s. So we got x3 minus x1 divided by 2. Now, you'll remember that whenever you have a fraction divided by a fraction, you flip the bottom one and multiply. So this is the same thing as y3 minus y1 divided by 2 times 2 over x3 minus x1. I almost forgot to flip it. So the 2's here will cancel out, and I'm left with y3 minus y1 on the top and x3 minus x1 on the bottom. And you'll notice that my slopes are the same. That means that I have just proven that no matter what values you have for your x's and y's in your triangle, that the midsegment will always be parallel to that third side. Now I would be done, except for there's another part to this theorem, and that's the third side is half the length. So I'm going to use what I just proved to help me out with this. So I know that this side right here is parallel to this side right here. So the midsegment is parallel to the third side. And that's going to help me because I know some things about parallel lines and transversals. I don't think we've talked about it in class. Just take my word for it. We can prove it sometime if you want to. But anytime you have two parallel lines cut by a transversal, which is another line, then the corresponding angles are congruent. Now, corresponding angles are angles that are in the same position on the two lines. So if it's on this side of this line, it's going to be on the same, this side of this line. So these two things are called corresponding angles. So down here we have more corresponding angles. This angle corresponds to this angle. And since it's two lines in a transversal, they are congruent. Now if you want to, you can say, hey, this angle B up here is in both triangles and it's congruent to itself. You don't have to say that though, because we already have angle-angle similarity. Whenever we talked about the ways to prove triangles congruent, we mentioned that angle-angle-angle is not congruent, but similar. The thing about similar triangles is that their sides, corresponding sides, are proportional, which means that whatever the ratio is between the two sides holds for all three. So if we can figure out the ratio of this side to this entire part, so from A to D and from A to B, oh, my bad, I need to change that up, it's all one part. I gotta delete it real quick. If we can find out D to B, which is in the little triangle, and A to B, which is in the big triangle, then that ratio will hold true for all three sides. Well, since this is the midpoint, let's say that this was z. That means that this part right here would also be z. So b to d, the length of that is z. And the reason why I picked z, once again, is if I picked a number, it would just be an example. So I pick an unknown. That way it will work no matter what number I use. So z is the length of side db. So side AB is z plus z, which is 2z. So you can see that the length of the side of a smaller triangle is half the length of the side of a bigger triangle. That means the ratio between the two sides is 1 to 2, which means that the length of the midsegment is half of the length of their third side. Now that was a lot of work to prove this theorem. So let me show you how you might use it. So here we have a triangle. Let's say that this part's congruent to this part's congruent to this part. And then they tell us that this segment right here is x plus 5, and this segment right here is 3x plus 4. Now, since we know that these two parts are congruent, we know this is a midpoint. Since these two parts are congruent, we know this is a midpoint. So this segment right here connects two midpoints, which means it is a midsegment. That tells us two things. It's parallel to this side, and it's half the length, which means that if we double this side, we get this side. So the relationship between the two sides here is that if we take 2 of the x plus 5 sides, that would equal 1 of the 3x plus 4 sides. And now we can figure out what x is. We just have to solve this equation. 2x plus 10 is equal to 3x plus 4. Remember, pick on the little guy, so I'm going to subtract 2x from both sides. And I want to also subtract 4 from both sides because I'm trying to get the x over here by itself. And so I get 6 is equal to x. And there's an example of how you might use the midsegment theorem. All right, make sure you look back on this example as you try to do your worksheet. And I hope you guys have a good one.